Hello, this is Christof Ebert of Vector Consulting Services, and I'm together with Jonas Wolf. We are going to present about functional safety with ISO 26262. Welcome to this webinar. Let me first start with a few introductory comments, and then we are going to this webinar content. First, you are free to ask questions, which we will directly answer in parallel. My colleague will do that, and you will see a window which is question and answers on the upper right corner, and you can directly type in your questions. That makes it easier for us to answer these questions in parallel. This webinar is part of a series of webinars which cover the full scope of functional safety related solutions of the Vector Group, namely a first part which looks into principles and practice. That is what we are doing now. A second one which we will host on the 12th of November, which is about using prevision for modeling throughout the life cycle, and part 3, which is on our Microsoft Safe solution. That will be 2 times, namely on the 18th and 21st of November. The structure of this first part on principles and practice is broken into 4 parts. First, we will briefly introduce to the challenges with implementing functional safety. Second, we look into some basic concepts. Third, we provide experiences. That will be the practical part. And 4, and concluding, a couple of success factors and a summary of this webinar. Brief introduction to the group and ourselves. Vector worldwide has among 1,200 persons, steadily increasing. We are active around the world in all major locations where there is automotive industry. The Vector Consulting Services, where I'm a managing director, is active in 3 topics, namely engineering, management, and support for change. And functional safety is one of the key topics of our experience, where we are active on a worldwide basis. We are consulting in a variety of industries. About half, 2/3 of our activities in the automotive sector, but we are also active in other industry domains with critical systems, mainly aerospace, energy, medical, railway, and critical IT systems. This also helps to cross-fertilize across different industries and therefore learn from each other. Our safety solution portfolio can be broken into 3 domains, which I will briefly introduce just to give you a background of our competencies. First of all, the introduction of safety processes, be it that we help companies to ramp up efficiently on the ISO 26262, building safety culture, training, coaching, mentoring, and also the adequate tool support. Second, to support in safety management, such as interim safety management or safety audits, supplier audits. And thirdly, to help in safety engineering, be it with our Microsoft Safe solutions, be it with dedicated safety methods like hazard and risk analysis, etc., or helping in developing and reviewing safety concepts. Our customer basis is, from an automotive perspective, obviously if we talk about the 26262, split into OEMs and Tier 1, and you see from the different companies that we are in a worldwide engagement on these different topics in the application of safety management, safety engineering. After this brief introduction, I would like to go into explaining the major concepts of functional safety in the ISO 26262. And I guess a good starting part is always to think in terms of what is the risk which we face in automotive industry. And I have just summarized here a set of recent callbacks which we had this year. And what we can see is that in different parts of the world, we always have a similar perception, which is that electronic components do not work as they have been intended, and therefore there's a risk of safety-related malfunctions, and this, of course, includes then also the risk of liability. Functional safety has a very broad exposure across all EE functions, and this is mainly due to the fact that we have an increasing interdependency of the EE-related functions. If you think about ESP, it's a dynamic function in the car, and that means that there are different type of braking effects, for instance, which means that it is not anymore a single device, as we could, for instance, see with the airbag, but it is a connection of different ECUs, which then can create maybe unintended side effects because something has not been observed in the functional specification. That is, with an increasing amount of EE functions, we also have an increasing complexity, which again makes the full hazard analysis at the beginning or the implementation of safety function increasingly difficult. The exposure is increasing. A third reason why companies these days look increasingly to functional safety, and specifically the 26262 standard, is that since its release in November 2011, that is 2 years ago, we have seen a very steep ramp up starting in Europe, but fast growing into Asia and North America, where the standard is correctly seen as a mandatory way of implementing functional safety in the EE-related development in the automotive industry. We see it also relating towards combinations of, for instance, other development processes as SPICE, CMMI, which help to facilitate the 26262 implementation. On the other side, we also see still that a lot of the activities which have, for instance, been historically been driven out of the IEC 61508, which was a kind of a predecessor, which is a bit more high level than the 26262 and which is not industry specific, that it is not yet integrated really to the life cycle, which has two major drawbacks. One, that certain activities could be overlooked, or that on the other side, some activities are redundant. Both is unfortunate, because if something is overlooked, the exposure will increase, that some safety risks are not adequately addressed. If something is redundantly implemented, such as, for instance, different type of software test activities, there's a high risk that the test activities in total cost more than what is really necessary. That is, there's also an exposure towards an overly complex perception of how the standard should be used. We often hear from customers that would claim, well, this 26262 is expensive or will cost too much. When we look into the process, what we often see is that there's a lot of redundancy, because it's not consistently integrated to the product life cycle. The impact is rather wide in the entire life cycle, specifically the interfaces from the OEM to the supplier, which means that with all these different steps, there is a risk of gaps, of inconsistencies that have to be avoided or mitigated. Again, this is about consistent implementation of the standard, specifically where there are interfaces from one to another party. We can also see in that picture that the ISO 26262 addresses both management and engineering activities. At times, people who are experienced with functional safety assume that it's primarily about engineering, that is performing fault tree analysis or hazard analysis, have the safety case, do all the necessary checks, and finally deliver this package. But there's also an amount of management activities which have to do with implementing a safety culture. For instance, if there is a defect in the field, how to cope with these kind of defects, how to analyze and how to trace it back into changes, because this is what at the end of the day is very critical if there happens to be an accident and we have seen that recently in newspapers, that some OEMs have faced severe challenges because they were not able to prove in front of legal authorities that they have really consistently implemented the standard with all necessary documentation. For instance, I recall an example a few days ago where an OEM was faced that his static code analysis was insufficient, basically not following MISRA standards, which is state of the practice. And these kind of deficiencies in the age of high complex automotive functionality can be very critical at the moment where there are lawsuits. Now, functional safety is not necessarily linked to a specific standard. We should be very clear on that. The ISO 26262 is a set of best practice, but it can be substituted by equal set of best practices which maybe a company has applied over the past years, independent of the standard. What we want to emphasize is very clearly that there are many methods which could be applied in order to prevent defects from occurring, in order to detect defects by means of different type of analysis, fault tolerance, which plays an increasing role in complex system, and failure prevention. But all that means that it needs to be an informed judgment to make sure that the methods would not create, as I said a bit earlier, gaps on one side or overlaps on the other side. Both is of a risk, the one of a liability risk, the other one on a commercial risk. So the optimum is where the standard is tailored in a way which is suitable to the specific company, to the specific components, to the systems, etc. And this is exactly what we see in practice as the most critical aspect, that companies on one side have gaps which they are not even aware of, or blind spots of methods not being adequately used, and on the other side waste a lot of energy on overhead methods which could be reduced and therefore also save effort. The standard itself is not exactly easy to digest, which has to do that it has many books. There's a set of 10 different books, which you can see on the picture, where some general topics like vocabulary, the guidelines, how to use it, then specific analysis like the ASIL classification, and then we have the life cycle, which starts with concept, has the product development with system, software, hardware, and production operation, the management of functional safety. This is safety management, safety culture, and finally the support process such as config management, tools, etc. Now, with these 10 books, 10 parts of the standard, we can see that we have a lot of best practices mentioned in the standard, which boils down to 500 pages of the current standard volume and 600 different requirements. And suddenly we realize, well, this is not peanuts. And it certainly needs a good understanding of how to best address these requirements without creating now an extra overhead. We should also be very clear that there is a big difference between requirements suitable for a high-risk environment like an ASIL CD or a rather low risk where many of the requirements really boil down to something which you probably already do that applies for ASIL A. Developing safe products means that we would have a clear obligation in terms of liability to produce a product which is safe, where our customers understand it has been produced with understanding the best practices, and which conforms to the state-of-the-art in science and technology. State-of-the-art is what is covered by standards and by publications. Now, in case of lawsuits, the primary concept of state-of-the-practice is what is covered by standards, because there we can be sure that it has been digested by different industry perspectives. You might know that the ISO 26262 was not coined by some academic body, but it was really written by automotive OEM and Tier 1. And as such, the 26262 today is considered worldwide as the baseline for best practice from an automotive perspective in EE development. Liability means that we have a starting point today in terms of legal perspective, which is product liability. If you put a product into service, the level of safety is what has to be expected by general public, and we then have a manufacturer's liability if the product creates an accident where the manufacturer has to prove that he is not responsible. And this is exactly the trap which many of us tend to neglect, that to prove that it's not our responsibility means that our processes are in good shape, that we have the right documentation to show in front of an external legal authority or expert who would look into our processes that throughout the life cycle we have considered traceable safety requirements and their respective implementation. Legal liability, as I said earlier, means it's based on the state-of-the-art in science and technology, that is the different standards, such as the ISO 26262, but also maturity models, such as the CMI or automotive SPICE, and the application of this basic body of knowledge is expected at the moment where you have to prove, as I said on the previous slide, that you had not failed to implement such a best practice. As long as we are forward-looking, we can apply all kind of deviations. We can skip something. But at the moment where we are obliged to prove that our life cycle is consistent with the 26262, it's better that we have rather rigorous documentation for the life cycle that these different requirements of the standard have been addressed. The scope of the 26262 is safety-related systems, which relate to electronic systems in serious passenger cars up to 3.5 tons. In other words, the specific scope of the standard is on automotive vehicles which are on the road in series production. However, we see in practice with many of our customers increasingly a usage of the standard also in other vehicle. The reason being pretty simple. On one side, if I'm a tier 1 supplier, I don't want to have too many, let's say, similar standard variations, so I look to the one which is the strongest, and that's definitely today the 26262. On the other side, we also see, for instance, in the truck or agriculture domain, that even OEMs would look increasingly to 26262 because there's the broadest experience and body of knowledge about how to best implement it, how to use the necessary support tools in order to implement that standard adequately. Let's now zoom a little bit into the standard, just that we have a good understanding. I'm not going to read that all for you, because I'm sure that most of you have already looked into the standard, and the idea of the webinar is to give best practices. But as I said earlier, we have 10 parts, and those which are relevant is first the management of functional safety throughout the life cycle, specifically the role of the safety manager in the life cycle and overall safety management in terms of how are people trained, how are they educated, how are they empowered in terms of decision making. Then from a life cycle perspective, we have first the concept phase where items are selected which have safety risks. Then we initiate the life cycle, we perform the hazard analysis and risk analysis. And finally, we deliver a functional safety concept, which is basically enriching the life cycle with a perspective of functional safety. The parts 4, 5, 6 look into the development itself, which is system level. That's the upper part of the V. For system design, the component classification and the item classification and later integration on the right side of the V. And then on the hardware side, the hardware design, the evaluation of the different components and the integration, same on the software side. Then we have book 8, which I recommend to all of you who also want to cross-check their support process, specifically config management, verification, documentation, qualification. There are a couple of interesting books. I admit that book 8 is my favorite book because there's a couple of quite nice topics which we are often confronted in practice, such as how do we specify a safety requirement, how do we work in distributed development like suppliers, like different organizations in our company, or what exactly is the meaning of proven in use, which is an argument which we often have. Book 9 is then giving us some support for safety analysis, and book 10 is then finally a guideline how to apply the standard. That is in essence what I just explained about using the different books. We split that into 3 major topics, which is management, development, and support processes, with the details I was just giving. A basic concept, which is the ASIL classification, relates the typical risk calculation of severity and probability into 3 dimensions, which is exposure, controllability, integrity. And the integrity is, if you want, a counterweight to an increasing exposure and less controllability and higher severity. That is, we bring in a new component which increases the risk, means that we have also to look to a higher integrity level, which is numbered A, B, C, D. And by applying the necessary methods which are required by the standard, we come back to an acceptable risk. This is the simple logic of the ASIL classification, and what will the standard really contribute. There are different types of risk which we in engineering subdivide into what is random and what is systematic. Random typically translates into hardware faults, where we work, for instance, with redundancy, with self-diagnosis, etc. On the software side, we see systematic defects. They are systematic because if a defect is in the software, it remains there. It has nothing to do with age, with temperature whatsoever, which is what causes random defects. It's really there and will sooner or later hurt us. And this has to be covered by dedicated design methods, analysis techniques, traceability, defensive programming, etc. The ASIL level is determined by looking to severity. It's the left column. The exposure, which we see in terms of 4 different classes. And then we have the different controllability level. This is to which degree are we able, in case of malfunctions, to still recover. And then what we see is, and that's the interesting part, is that lower section where we can see that if the exposure is rather low, if the controllability is rather high, quality management methods will suffice. However, if we run into low controllability, high exposure, at a high severity, we need ASIL-CD. ASIL-CD is clearly the bulk of what the standard really talks in terms of safety requirements. Let's look to a brief example, which is a simplified brake-by-wire system to show how these different conditions are connected. First, we look always to failure mode. That's what we determine with an FMEA at a given state, which helps us to delineate the exposure and the severity and also the controllability. And then we classify, as in that first line, where we say no braking effect at a high speed means a high exposure. We cannot brake. We cannot really do much. The controllability is also high here. The severity, given the speed on the highway, is rather high, and we run up into a high ASIL classification. Now, on the other side, if we go with a very slow speed, like in parking, and would look to the failure mode of an asymmetric braking at a dry road, which has not much traffic, we can immediately see that also the exposure is very high. I mean, it will definitely lead towards an accident. The accident itself is rather low profile because we are on a small street with low speed. So this relates to a very small level of severity, because there will be not really much accident, which translates then finally into an ASIL-A, which has a much smaller amount of safety requirements. And that's the whole logic behind the previous table, that we have to connect these different failure modes and assess them. Now, what we see in practice often is that different persons would come to different judgment, and this is one of the topics where we get engaged by customers. I recall a case where an OEM would have two Tier 1 suppliers. One came from North America, the other one from Europe, and they grouped the same kind of equipment or component, it was a dual sourcing, into two different ASIL levels. And then it's important that we get these different parties at the table in order to identify which is the ASIL level which should be taken, because obviously there's a cost behind, and if one supplier claims, well, I see a lower ASIL level, and for that reason offers it at a lower price, this cannot be compared with the higher ASIL level of the other one, because maybe there was a misclassification, and this is exactly where our expertise would also come into the picture. Let's briefly look into some experiences in order to show how these concepts translate into practice. And a first one, and we obviously cover here what we see as most relevant in our practical projects, is having a safety plan. The safety plan relates the different activities throughout the life cycle into concrete processes, such as the development processes, which have to be taken, maybe depending on the ASIL level, the interface agreements which have to be set up, project planning, where, for instance, activities related to safety management or to safety analysis have to be budgeted, and finally project manual, which helps then also to document the different activities. The benefit of a consistent process, which of course should be tailorable, is clearly that independent of the specific activity, like a late requirement change, the activities related to functional safety would always be consistently implemented. Another topic which we often see very much debated in industry is the usage of the development interface agreement, or DIA. Here's a very simple way of implementing it, which you can do with an Excel sheet, where the different artifacts which have to be delivered are first of all precisely specified, and then the responsibility is defined, and that should be done preferably at the very beginning of the project, because it's obviously part of the relationship management or the interface management with the supplier, we've been called into a lot of such discussions. We're too late. The question came on the table, who has to deliver which kind of document, or who has to do which kind of analysis, or who has to do which kind of verification, validation activity. That, of course, much more at the level of integration, where it's getting really costly. And for that reason, it's good to do that in the beginning, and then also make clear who has which responsibility, when it is to be budgeted, in order to avoid a situation, as we observe, unfortunately, quite frequently, that a component could not be released by a supplier, and therefore also slows down the whole release process, just because some safety-related activity has to be still processed, even if everyone around the table would say, well, but we are actually on a critical path and we are getting late. But obviously, if you would skip the activity, you would run in severe difficulty at the moment when somebody wants to assess your behaviors. Speaking about supplier management, generally speaking, we recommend that the OEM Tier 1 or the Tier 1, Tier 2 regularly look to their safety critical function and who is performing which kind of check. And that starts with the hazard analysis, because that should be shared. We always learn that it should be done on the next higher abstraction level, that is from an OEM perspective and a systems perspective. But that also means that the different parties should share the same background and not just get a set of very specific functional requirements, but also what is the reasoning behind these safety requirements. So we recommend performing joint workshops, specifically in the early phases, on requirements, on design, in order to come to a mutual understanding about a safety strategy. On the other side of the whole life cycle activities, when we talk about the DIA, or when we talked about the safety workshops, that is on the left side, upper left side of the V. Now, on the right side, or in terms of how are we actually performing our safety requirements, it's also helpful to perform audits and assessment, where the safety audit is primarily looking into checking whether necessary processes have been done. We recommend doing that together with other audits, such as SPI, CMI. That can be done in a very lean way, just to make sure that companies actually perform their safety-related requirements. The safety assessment, this is more in-depth, but would also then help to find out, is there any kind of systematic weakness. We see the value of a safety assessment clearly in terms of identifying how could a safety process be made more efficient, how can gaps be detected, which maybe on a safety audit would not easily be observable, but with the safety assessment you can look into these domains. Now, all these activities benefit from a consistent and thorough tool support, and what we want to show briefly is how to do that with tool base. We use here the vector prevision tool. As I mentioned, there will be a specific webinar, part 2, on the 12th November, where we look more into the prevision context. But for the moment, what I want to emphasize is tool support ensures consistency. You can combine tools in order to give you warnings, in order to show if there is a change or requirement, what kind of methods have to be applied in order to make sure that the change is adequately handled. Here, as the example, is the HERA, the hazard analysis, the risk assessment, where we, for instance, use the tool to look into specific operational scenarios, facilitate an ASIL calculation based on the initial inputs, and I think most important in terms of effort, to support traceability of safety goals into the requirements and design artifacts, and ensure consistency in both directions. For the FMEA support, it's helpful to cover the different failure modes and effects and then see what would be the causes, what kind of prevention measures. This gives a completeness, but also helps you in order to find out, do I need at one or the other side to intensify my safety-related measures. My coverage checks, that's a quite useful measurement to simply see what's the percentage of coverage in terms of the initial FMEA. Or if we go a little bit more into the design, the support for analysis and design could, for instance, mean that dependencies would be adequately managed, that the functional and technical safety concept, including the acyl decomposition and the necessary test cases, are all lined up, and therefore it's a good instrument, and also to see how in the life cycle the different safety requirements are addressed. With this set of experiences, I would like to look into some success factors and then conclude the webinar. Feel free to ask further questions in the question and answers window of this webinar. For those of you who listen to the webinar, which as a recorded webinar, you are aware that we record the webinars to make it available after the live broadcast. For those of you who listen to that recorded webinar, obviously you cannot ask the questions directly, but feel free to send an email. We're going to show our email address at the end of this webinar. So what we see increasingly is a steep increase of complexity, while at the same time the different competencies do not grow at the same speed. The reason be pretty simple. On one side, it's a simple lack of resources, which do not cope with the steep complexity increase. But I think worse, because it shows also inefficiencies in many companies, is that the process, the tool support are not adequately ramping up in parallel with the complexity. A success factor clearly is that companies change towards a clear safety culture. We put here as a contrast a classic development culture and a safety culture. For instance, one topic which I hear quite frequently is that people tell me, well, we have not enough budget or time to do all these safety measures. This is really necessary. Rather than debating the necessity, I would rather plan in terms of what is the risk which we face and how are we going to most efficiently address it. I have in the past years not seen a single customer where we can clearly say all processes are most efficient. We typically see a single to double-digit percentage in terms of efficiency potential, just because a couple of activities are just traditionally or organically grown over the past years and therefore are quite too expensive. As a point in case, take test effort. Many companies spend 60–70% of the life cycle cost on validation activities, verification activities, which can in most cases be reduced just by looking towards what kind of strategies behind, what kind of tool support, test automation, static code analysis, etc. Is used. How can test cases be reduced without reducing the coverage? As a rule of thumb, what we see is that specifically test cases are to 20–30% of the test cases are redundant, don't follow really a clear cut methodology in terms of what is the selection criteria, how would they be applied in regression cases. And these are obviously big levers in order to use the available budget in a much more effective way. And this is what I mean, for instance, with that first line. So functional safety is not necessarily expensive. Obviously, ASIL D is much more expensive than an ASIL A, but that's also comparing apples and pears. But if we stay within a specific ASIL level, you see still a big variety of to which degree you implement the methods, and this is the kind of efficiency saving which I want to emphasize. Functional safety is not primarily related to having the right methods in place. It also relates towards starting with product architecture, like what kind of self-diagnosis, what kind of redundancy concepts, etc. But also the people in their respective roles. For instance, we still see sometimes dedicated safety teams which run more or less in parallel to the regular development, like in the old days, the quality teams, which obviously is not exactly the best organizational layout, because that always provokes people to say, well, our safety engineers will kind of govern the safety principles and will help us. We strongly recommend including safety as an integral part of normal project management, rather than putting that as full separate teams which occasionally audit the processes, which is typically much more time-consuming and ineffective. Where do we go from here? From an OEM perspective, which certainly have the longest tradition in implementing functional safety, what we see is here and there some sharpening of the process, making more efficient safety processes in order to comply with the safety standard, and specifically to help their suppliers. From a perspective of suppliers of established safety critical components, such as an airbag system, or such as a component used in a dynamic ESP system. I mean, on those topics, it's primarily to better connect with the OEMs in terms of getting immediate feedback from field observation, but also supporting the safety case, also better splitting who is doing what in terms of the safety-related requirements. For the suppliers of new innovative components, that holds also for new OEMs, the major challenge is how fast can they ramp up the learning curve. We see that specifically with new driver assistance functions, the complete electric powertrain, but also if we see, for instance, AutoSAR being increasingly used in ECU design, there's a lot of leverage which you can use from your respective next-tier suppliers, such as Vector, with our huge AutoSAR experience, can very much support also the efficient usage of AutoSAR components in your design, rather than trying to engineer all these safety concepts again and again. The standard itself is certainly not frozen. At the moment, we have the standard in use since 2 years. That is, we are learning about what works, where we need maybe some changes, some more facilitation, maybe replacing some best practices, etc. So clearly the standard will further grow. We see a quite strong evolution need in terms of where safety meets security, because within a growing amount of driver assistance and infotainment, which are increasingly connected, security directly impacts functional safety. This is today in the 2626.2 not yet sufficiently handled. That will certainly evolve over the next years. Also, for high voltage systems, we see an increasing need to deal that with these kind of systems, like in hybrid cars or e-cars, in a more consistent way. That's also not yet fully instrumental in the 2626.2. So there will be further releases of that standard over time. Safety capabilities certainly will become part of standard supply evaluations. I mentioned the need for safety audits, but I recommend also combined safety workshops. In other words, there's a couple of challenges which depend on your position in industry, on your position into the life cycle, but also your previous experience with functional safety, where it's clearly helpful to work together with a competent partner to focus on where it really makes most sense. That brings me to the end, and we now have still time to address a couple of questions live, which is what my colleague Jonas Wolf will be doing. He had been noting a zillion of questions, as I saw, and will filter out a couple of those and directly highlight it.
Hello, and yeah, I'll just repeat some of the questions we had. Of course, the question we hear a lot of times is about the scope of the ISO 26262. Is it applicable to, for instance, truck development or motorcycle development? And as Mr. Ebert has shown you the exact scope, the ISO has a very narrow scope on passenger cars with less than 3.5 tons. There should be definitely a processes adaptable from the ISO for your development. Another question was if the ISO 26262 supports is now supported in AUTOSAR, and yeah, if you have a look at the vector site, you can see that we provide you with some help in implementing ISO 26262 using AUTOSAR with the MicroSAR Safe solution, where we have an operating system that is certified up to ASIL D, and of course the end-to-end protection library of AUTOSAR 4 helps you implement safety mechanisms. And just let me see. We always get a lot of questions with respect to the effort that needs to be additionally put into development. Unfortunately, the question can't be answered like with a percentage X. It just depends on what are your current capabilities, what are you comparing, what is your reference value for the additional effort. For instance, if you have a SPICE level 3 and implement all the requirements for traceability, you will have absolutely no additional effort that is introduced by the ISO 26262. And let me see if we have another question that is worth just a second. Yeah, so the question is if there are any security aspects addressed in the ISO and if they're going to be addressed. Security is an emerging field in automotive industry. There are areas where it will be addressed in AUTOSAR. By now, the ISO 26262 only addresses the safety of a vehicle and the accidental misuse of a, for instance, assistance function, but it does not address any security functions. Yeah, and I think I got a lot of more questions, but they're hard to figure out. Let's go just one question. Yeah, there was one question if the with the introduction of the ISO 26262, the FMEA will be eliminated, which is of course definitely not the case. The ISO requires you from ASIL A to perform an FMEA on hardware level for every system you develop.
Hello, this is Christof Ebert again, and I would like to conclude this webinar. Thank you to all of you for joining the webinar, for asking questions. We received quite a lot of questions in written format via the chat function, which my colleague Jonas Wolf is still addressing and will finalize that. For all of you who have follow-up questions, do not hesitate to contact us with email or via our website. The Vector website for functional safety is www.vector.com/safety, or you might also contact us at www.vector.com/consulting. My own email address where you can ask a follow-up question is at christof.ebert@vector.com. For those who have listened to the recorded version, I suggest that in case of question you just go directly to the mentioned website. I would also like to remind you that this was the first part of a 3-part webinar, with the 2 other parts being on microcell safe and also on modeling with our prevision tool, so that you can, for instance, see how the safety case is handled in practice. In case of concrete topics which you want to address in terms of how to best ramp up with functional safety in your company, or if you are in need of interim safety manager or other support, also do not hesitate to contact me at my email address. At this point, I want to conclude the webinar and thank you very much. Wish you good success with functional safety, and do not forget to balance the needs in order to achieve effectiveness in implementing the standard and implementing functional safety concepts, but also the efficiency in order to stay cost effective and do not create overheads. Thank you very much, and bye.